Hello, ladies and gentlemen, and welcome once again to our virtual classroom. Today, we're going to be going over comparing and ordering decimals. Comparing and ordering decimals. And really simply, if you see this table right here, we see a general breakdown of how we name these decimals, beginning with the ones place. For example, if you have something like 9, something like 11, something like 12. Notice that here on number 11, we have the 1 on the ones place. If you had a decimal, it would be right after the 1. On the 9, it would be 9, and then the decimal goes right there. On the 12, the 2 would be in the ones place. So that is the ones place. But what happens after the decimal? What happens after the ones place? What if we're breaking things down into smaller numbers? Well, after the 1, we have the tenths place. See here, for example, we have the 1/10. For example, you have something like 1.2. Here the 2 would be 2/10, or 0.9, that would be 9/10. Or if you have something like 10.5, that would be the 5 would be in the tenths place. That is to say 10 and 5/10 of the next number, or 1 and 2/10 of the next number. And here would be just 9/10. That's almost a 1 whole. Moving on, we have the hundredths place. For example, if you have something like 1.21, that would be 1 and 21 hundredths. That means that you have 2/10 and then 1/100th. If you have something like 2.01, that's 2 wholes and 1/100th of the next number, etc. Going down to the thousandths. That is 3 numbers after the decimal point, or 3 decimal places. 10 thousandths, that is 4 numbers after the decimal place. And then 100 thousandths, that would be 5 numbers after the decimal place, etc. And ladies and gentlemen, really what I want you to get from this short presentation is to understand that there's an infinite number of numbers between numbers. Okay, for example, if you take a whole, one whole, just one whole, like we have right here, and notice that I can express that whole in different ways. For example, on that first number line, I can take that one whole and express it in fourths. In other words, cut it into fourths. So I can cut this in half and cut each of those in halves. And notice how by doing so, I have split this whole into fourths. There's 4 different sections. And so this would be 1/4. If you have two sections, that would be 2/4 or 1/2 of the way there, right? 3 sections would be 3 out of 4, and then finally you have 1 whole. And I'm cutting it into fourths. There's 4 sections. That's why my denominators are 4, if they're not simplified. If I continue, ladies and gentlemen, notice that the next one is still 1 whole, but I can express that in eighths if I cut it in half and cut that half in half, and then cut each of those sections in half again. We can easily see that I now have 8 sections. And so each of these would represent 1/8. So 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and 8/8, or 1 whole, 1 whole. And notice how these match up perfectly. So 1/2 would be 2 out of 4 or 4 out of 8. That's halfway through. It's the same, different ways of saying the same thing. 1/4 is the exact same thing as having 2/8. In other words, if I have 1 whole and I cut it into 4 pieces and I take only one of those 4 pieces, it would be the exact same thing as cutting 1 whole into 8 equal pieces and taking 2 of those pieces. That's the exact same amount, right? But again, notice that my denominator is 8 because I've cut everything into eighths. That is, of course, without simplifying. But that is my denominator of 8. Well, ladies and gentlemen, what if I do the same exercise, do the same thing, but this time, instead of cutting the whole into fourths or into eighths, what if I cut it into tenths, into 10 pieces? So if I cut it in half and then cut each of those halves into 5 equal pieces, and notice that I did not do a very good job here, but let's just pretend that I did. All right, so let's just have 10 equal sized pieces. Notice how each of those would represent 1/10. And let me do this in a different color. Each of those would represent 1 tenths. So that would be 1/10, 2/10, 3/10, 4 out of 10. 5/10 would be exactly half. 6/10, 7/10, 8/10, 9/10, and finally we have 10/10, or just one whole. Well, ladies and gentlemen, that is precisely what we're doing when we use decimal, specifically the tenths place. The tenths place is the same thing as cutting one whole into 10 pieces. Notice how 1/10 is the exact same thing as 0.1. That's why we say 1/10. 2/10 is the same thing as 0.2. That's why we say 2/10. 3/10 the same thing as 0.3. 4/10 the same thing as 0.4. 5/10 or 1/2 the same thing as 0.5, etc. That's why we say tenths. In fact, that first decimal place is literally dividing one whole into tenths. So, ladies and gentlemen, if I were to cut this whole strip into 100, for example, if I were to cut into 100, that would be like cutting each of these into 10 pieces. So this 1/10, if I cut into 10 pieces, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Now there is 10 sections in between, then each one of those would represent 1/100th, or 1 out of 100, meaning that I need 100 of those little ones to make one whole. And there's 10 of those hundredths in each tenth. So that's how the decimal system is working. I'm cutting them into ever smaller sections. And a very good example of that is when you see a ruler, specifically the metric side, the centimeters. If you look at a ruler, if you look at the centimeters, notice that if you take 1 centimeter, if you cut that into 10, you now have millimeters. And actually a better example would be to take a whole meter stick. This would represent 1 whole meter. All right. If I cut that into tenths, you have what are called centimeters. So 1/10. 2/10 would be 20 centimeters. 3/10, 4/10. All right. So that would be literally 0.1 of a meter would be 10 centimeters. All right, and then I can cut that even further into millimeters. And you can cut that even further into smaller sections. That is what decimals allow us to do, to fill in the gaps between numbers. So having said that, ladies and gentlemen, let's look at some examples of this. So consider this number line. Notice the first number line is cutting things into tenths, but we're not just given one whole, we're actually given 2 wholes. We're given 2 wholes. So instead of saying, so 1/2 would still be 1, 2, 3, 4, 5. This would be 1/2, which would be 5 out of 10, or 5/10. 1 and 1/2, 1, 2, 3, 4. 1, 2, 3, 4, 5 would be right here. So that's 1 whole and 1/2. Or you can even say 1 whole and 5/10, or 1.5. Those are 3 different ways of saying the exact same thing. Just like this would be 1.1, 1.2, 1.3, 1.4, 1.5, until we get to 1.9, and then the next one would be 2.0, and then 2.1, etc. Notice the pattern that we're following. Now, in between those lines, we can fill in even some other numbers. So, for example, if we have 1 and 1.1, well, guess what? Right here would be 1. I can't even write that small, but that would be, let's say that I were to zoom in right there, you would see 1.01. Halfway through, you would see 1.05. Right before we get to 1.1, we have 1.09, and then we have 1.1. And you can cut things even smaller than that. So hopefully that's not too confusing. But as a better example, let's look at these down here. Where would I plot these numbers? For example, 2,500. Well, where would this go? Well, we can see that this is cut into tenths. So each of these represents 0.1. 0.3, so 0.4, 0.5 or 5/10 would be right here, 0.6, 0.7, 0.8, 0.9, and then it would be 1.01 whole. Well, if I'm looking at 0.25 or 2500ths, notice that we have 2/10. So 2/10 is right here. But it's not just 2/10, it's more than that. Now, we're not quite at 3/10, but we're halfway there. It would be right here, ladies and gentlemen. This is where 0.25 would be. 0.25 would be right here between 0.2 and 0.3. It would be right between them, right in the middle, 0.25. Now, what about something like 1.38? 1.38. Well, we have 1 whole and 3/10. 1 and 1, 2, 3/10. So this is where 1.3 is. And then 1.4 is over here. So it would actually be almost to 1.4. It would be right here. That's where 1 and 3800ths. So again, notice how the smaller the decimal is, so tens, hundreds, thousands, the more exact I can be. 0.5 would be exactly half of 1 whole. So 0.1, 0.2, 0.3, 0.4, 0.5 would be right over here. Exactly half. 2 and 3/10, well, here's 2, 2.1, 2.2, 2.3. 0.56 or 0.5 is right here. 0.6 is right here. So 0.56 would be a little bit more than half of that. 0.56. So notice how you can use a number line to plot these numbers and see which is the greatest and which is the least. But what you can also do, ladies and gentlemen, is simply stack the numbers vertically. For example, if I were to take these 3 numbers right here. So we have 2500ths, 1 and 3800ths, and then we have 5/10. Now notice, ladies and gentlemen, that I lined everything up vertically with the decimal. So the decimals are all lined up right here, which allows me to easily see, ladies and gentlemen, what is the highest place value that I have here. For example, here we can look at the ones place and notice that the first number has a 0 in the ones place, the second number has a 1 in the ones place, and the third number has a 0 in the ones place. So clearly the largest number is this one. You would just go from left to right. And the largest number that you see will be the largest number. So out of all of these, 1 and 3800ths is the largest number. Now, moving on, notice that again, if we line up the decimals, I can move on to the 10ths place. And looking at the 10ths place, ladies and gentlemen, notice that we already have this as the largest number. So now let me just compare this number and this number. We're going to compare 2500ths and 5/10ths. Well, notice that even though the top number has more digits, that's 2500ths, this number has a larger digit on the 10ths place, the 5. So automatically, this is the next largest number. That is the next largest number. So 5/10ths is bigger than 2500ths. So again, it's not about how many digits you have, it's about where those digits fall. The further left the largest number is, the larger the actual value of the number. So again, ladies and gentlemen, what I am saying is that out of these 3 numbers, the largest is 1 and 3800ths because it has 1 whole, followed by 5/10ths because that has 5/10ths. This one only has 2/10ths, and the smallest of these would be 2500. So again, don't look at the number of digits. Look at where those digits lie in relation to the decimal point. So ladies and gentlemen, in truth, this is supposed to be more of a review, and hopefully this was helpful to you. And with that in mind, I will see you next time.